Good morning. So this is the second part of the Modular Arithmetic Masterclass. And I'm going to start with something I have not done before, which is a couple of proofs. Because I have been using some facts that I have not proved. I mean, some properties of congruences, okay? Well, first of all, let's recap. What's the meaning of this? A is congruent with B modulo N.
When you divide A by N, it has the same remainder as when you divide B by N.
Okay. Is there any other way, maybe a simpler way to express that? I think I mentioned 3 different ways to define this. That's one. That's correct, okay. But there is another one I'm looking for, which is shorter to express, and then also simpler to express algebraically. You don't remember? Okay, I'll tell you. It's the difference. A minus B is a multiple of N. Do you agree? Do you see?
Yeah.
Yeah.
Okay. Now, how do you express this algebraically? I mean, like with an algebraic formula. I mean, algebraically, how are the multiples of N? So, or could you list me the multiples of N?
Zero N, 1N, 2N, 3N, 4N.
Okay, yes. And also minus N, minus 2N, minus 3N. So that's an integer multiplied by N. Okay? So to say that A minus B is a multiple of N is the same as saying this, that there is an integer, that exists an integer, such that A equal B plus IN. Well, maybe here I'm skipping a step. I mean, given what I said before, it would be A minus B equal E times N, but I'm just passing the B to the other side of the equality. So do you agree?
Yeah.
Do you see it? Okay, so but we're going to use this definition. I mean, to prove the following. How would you prove that if A, and let me just to short it, instead of saying A is congruent with B modulo N, I'm going to say A is equal to B modulo N, okay, or A is the same as B modulo N. Anyway, if A and B are congruent modulo N, and C and D are also the same modulo N, from that we can conclude that A plus C is congruent with B plus D modulo N. But how do we prove that? So, well, let me show you. From the first one, well, algebraically, what is this is what we wrote above. There is an integer I such that A equal B plus IN. Now, the second one is similar, but let's use a different variable, I mean, a different letter instead of I, because there is no guarantee that it's the same one, no? I mean, so this for the second one, that means there is an integer J, let's call it J, such that C equal D plus JN. Okay, do you see that? Do you see how the premise, these two premises can be written this way, no?
Yeah.
Okay, so then what we do is because we want to get to A plus C and B plus D, well, we add these two equalities, 1 and 2, and we get this. But then you can rewrite the right-hand side, taking common factor N and rearranging, you can write it this way. You see?
Yeah.
Yeah.
Therefore, there is an integer, I plus j, which is I plus j, such that a plus c equal b plus d. So a plus c is equal to b plus d plus a multiple of n. Okay, so that therefore a plus c is the same as b plus d modulo n. Do you understand?
Yeah.
So that's the
Yeah.
proof. Okay. Now, so now I'm going to put you an exercise. So we have this, and how would you prove this? That if A is congruent with B and C is congruent with D, both modulo n, then the product AC is congruent with BD. Could you try? I mean, do you have a pencil and paper or pen and paper?
Yeah.